Hi all, welcome back to the security room, the best room at the conference. Don't tell that to the other rooms. I'm Maya, I'm a track host. I was on the program committee to help select the security talks. I'm here to introduce Rita and Mishra, who are going to give a great talk on Secrets Store CSI Driver. When the talk is over, please rate the talk in the shed. And if you're just coming in now, there's still a lot of seats over here, so you can please come sit down and listen to our wonderful presenters. Thank you.
Thanks, Maya.
Hey everyone, last day of KubeCon. Really appreciate you guys being here. So today we're going to talk about the Secrets Store CSI Driver so that you can bring your own enterprise secret stores to your Kubernetes clusters.
I don't need that. So this is Rita Zhang. She's a software engineer for Microsoft. She lives in San Francisco, works on the container upstream team for K8s. She's also the maintainer of Secrets Store CSI Driver. She's written like most of the code. I've contributed probably like 10, 15%. You can all go to the contributors on GitHub and then figure that out. And then she's also written a key vault driver for implementation on flex volumes, and is also the kind of one of the maintainers for the Open Policy Gatekeeper project. Yeah, that's fine. Try again. There you go.
And here we have Mishra. He is a team lead and DevRel at HashiCorp, and he is based in Vancouver. And he is a core provider maintainer for Helm, Virtual Kubelet, and as well as this Secret Store CSI Driver. And when he's not coding, he likes to DJ, I believe.
You had to say that. I forgot what she loves dogs, by the way. I had to say that. I didn't say that.
Okay.
All right, so let's get into it. So the Kubernetes database. So before we get into any CSI interface or driver implementations or the vault or the key vault, we'll talk about Kubernetes itself. So Kubernetes, as you know, when you use Kubernetes using kubectl, you interact with the Kubernetes API server. The Kubernetes API server is interacting and storing and retrieving objects from etcd. So etcd is your persistent store, is the stateful part of the whole system. And if you want to use secrets for your pods and your containers and your application in Kubernetes, you end up using Kubernetes secrets. So Kubernetes secrets, out of the box, it does base64 encoding and stores stuff in plain text in etcd. So the problem with that is if someone gets access to the etcd API or gets access to the etcd CTL, they can just list and kind of see your plain text passwords, or they could be a database root password, which is unfortunate if they get access to that, or if it's a cloud resource, a cloud API token, for example, for Azure, Microsoft, for AWS or Google, they can create more resources or delete your resources and things like that. So to be honest, it's not a good situation to be in. You want to prevent against that. So kind of talk about the life cycle of a secret. Secret in Kubernetes. So how do you go about creating a secret? So let's say I wanted to use a secret for my pod. First, I'll create a secret using kubectl or using the API. So you go kubectl create secret generic, and this I'm just creating a generic secret. And then you submit that to the Kubernetes API server, and the API server stores it in etcd. And then let's say some pod wants to use the secret, they'll just reference it in the pod spec. They'll say, I need this secret mounted at this place. And the way this works is when you submit the pod spec using kubectl to the API server, the kubelet is responsible for creating the pod on the Kubernetes node. Once the pod comes online, kubelet actually does the mounting of the secret into the container file system. And then the container process might be your application, just reads it off of disk or environment variables, and off we go. So that's kind of the workflow, right? So I know most of you already have your own data stores, your own keep secret stores that you might be using, maybe your cloud provider secret store, maybe something like Vault or so on. So what if you wanted to just use those secret stores directly and didn't really want to interact with the Kubernetes secrets and how to bring in those secrets into Kubernetes? So why should Kubernetes be different? That's kind of the premise of it.
That is a great question. So introducing the Secret Store CSI Driver. Much like how Kubernetes attach Kubernetes secrets to pods, the Secret Store CSI Driver does exactly that. So when you create a pod, the API server schedules the pod on a node. Then the kubelet looks at the pod definition and sees, hey, it looks like you want to attach a volume. And the volume uses this Secrets Store CSI driver. Then it looks for all the volume attributes to be used to authenticate the CSI driver against your Secrets Store API service. Then once you're authenticated, then the content is attached to the container file system. And then the volume is attached as a temp.fs volume. So before we go further, you might wonder, what is a CSI driver? So CSI stands for Container Storage Interface. So this was GA'd back in 1.13 of Kubernetes. And it was originally designed so that there's a standard way to expose all the different storage systems to Kubernetes, to container workloads for all the different container orchestrators like Kubernetes. So why do we like this? Well, with this standard in place, and a storage provider can basically write the extension without ever touching the core Kubernetes code base. Now, this is really, really nice because then you can release, you can manage your own release cycle, and the code itself lives outside of Kubernetes. And all you have to do as a user, all you have to do is deploy the plugin on your cluster and make sure that it's available on each node. And the user, when they use it, it will have the exact same experience across all the different storage systems. So you can create PVs, PVCs, storage class with the exact same experience. So with the Secrets Store CSI driver, it is no different. So once you deploy the plugin, then, as I mentioned earlier, then the driver can then attach the secret to your pod. And in 1.15, and I want to highlight this awesome PR, the inline CSI inline volume feature was introduced. Why is this really important? Well, for this particular case, we wanted to make sure that the CSI volume Secret Store CSI volume plugin works exactly the same way as when we used to have it for Key Vault Flex volume, so that when you create a Secret Store volume, you can essentially define that volume and provide all the attributes right within the pod definition. And as an example, here, as you can see, this is a pod definition. And the user basically has to specify, for this volume, I want to use a Secret Store CSI driver, and here are the volume attribute for the provider Azure. And because this driver is built with a provider interface, all you have to do is specify what provider you want to use. And currently, we support Azure and HashiCorp Vault. And so by providing that and specifying the attributes needed for each provider, that information is used to authenticate against Azure Key Vault or HashiCorp Vault. And then once that information is, once you get the secret content, then all the secrets then is mounted into the container at this file path. So in order to use this plugin, you have two ways, right? So if you have an older cluster, let's say 1.13, which is the minimum required Kubernetes versions to run this particular plugin, you can basically create a PV and a PVC, and then in your pod, then you just reference a PVC. Now, for some of you who are maybe more advanced, who want to run a 1.15 alpha 2+, then you can start enjoy the inline volume feature that I mentioned earlier. And once again, this is really to give your end users a better user experience. So
the moral of the story is upgrade your Kubernetes clusters, not to the alpha one, but hopefully when 1.15 comes out stable.
But this does work, for 1.13 or 1.14. And once again, to use this feature, make sure you have the inline volume feature gate appended in your API server YAML, as well as your kubelet configurations. All right, so let's take a look at a demo.
I got you.
Thank you. So here, I'm going to first show you what a typical cluster looks like. And as you can see, I have 115 Alpha 2 running, and I have a 2-node agent cluster currently. And I'm going to use Helm. We have a Helm chart that makes it really easy for you to deploy all this stuff. And once all the resources deployed, then the specific plugin is installed on each one of these agent nodes. So let's see what that actually deployed. And you should always deploy in a different namespace compared to the actual workload. And as you can see here, the daemon set is actually the component that installs the plugin driver. And then once the plugin is in the node, then the kubelet can talk to it directly. Next, we're going to take a look at what a particular pod YAML looks like. And now I kind of mentioned that earlier in the presentation. But here, once again, for this demo, I'm using the Azure provider. And for this demo, I actually want to retrieve 2 different types of secret. One is a key, and one is a secret, right? Because those are the supported types in Azure Key Vault. So next, I'm going to apply and deploy this pod. So once this happens, and as I mentioned earlier, the kubelet sees that I want to use the CSI driver, and it then basically creates the pod. And during the creation process, the driver itself retrieves the content from Azure Key Vault, then grabs it, and then mounts it to the container.
This moment of truth.
Let's see how many secrets I get back. And as you can see, one is a secret, another one is a key. Very creative with my naming conventions. And let's just take a look at what one of them looks like. So this could be, like a database password or whatnot. And yeah, hola.
Cool.
So that was a demonstration of how you can deploy the Secrets Store CSI Driver and how you can continue to store and manage your secrets in an external secret store, but still can be mounted into your pod so that your applications can utilize those secrets. And as we mentioned earlier, what's also nice about this CSI driver is that we actually implemented a provider interface that allows different secret store providers to basically implement the APIs that we currently have, whereby providing the backend plumbing to access the secret store and a callback mechanism to mount the content into your target path. And here's an example of what that provider interface looks like. It's really, really simple. It basically just lets us know how to authenticate against the provider, and then how to retrieve a list of the content that you want to retrieve, and where to mount the path.
All right, another live demo. Don't you just love doing live demos, right? Imagine how I feel right now. All right, so let's try this if it works. Okay, flip. All right. So I'm not going to go into kind of the details of like installing the CSI driver. You saw that Rita kind of give a good kind of step-by-step using a help chart. You can use Kubernetes YAMLs as well if you want. So I'll also list all the things that are running here: kubectl, get pods. So here I have a Kubernetes cluster, also I think 115 alpha. That's running. In this case, I'm not following Rita's convention of like make sure the driver is in a different namespace than the application. I'm just putting it all on default, like many of us. Do not do it. I don't recommend that.
Don't do this at home.
Don't recommend that. But you know what? Like this is a demo, so it's fine. And I'm already running Vault. So Vault server is running in dev mode. So most of you who've used Vault before, Vault ships for the inbuilt dev mode. I'm just going to keep things simple. Do not do this in production as well. There's proper guides to making sure Vault's running in production properly. But in this case, this is just running as dev. I'm also port forwarding to that Vault Vault pod that you see up there, right there, so that I can locally interact with the, well, I'm not port forwarding to that pod. I will port forward now. Let's see if it works. OK, now I'm port forwarding to that pod, so I can interact with Vault now. So I can do Vault status if I know how to type. Vault status, OK, you see we get some output. We're running Vault version 1.1.1. It's unsealed. It's the dev not highly available cluster for this demo. All right, so let's start with kind of creating a secret in Vault. So we'll interact with just the key value store of Vault. And this provider that we've written is a very kind of early version. It's in alpha. So it doesn't support like all the different things that Vault does, which is like generating certificates, generating dynamic credentials for databases, cloud APIs and stuff. We're just going to use the key value store for now, just to keep things simple. So here, let's create a secret. So we'll do Vault KV. 1 second. Let me open my cheat sheet. OK, there you go. So we'll do a Vault KV put, and we'll store a secret. Let's call it KubeCon EU, and we'll say hello equals secret. All right, so here we have created the secret. Let's actually read it back. Vault KV read. I think it's get. Yep. Secret KubeCon EU. And then I can just do this. So we can list the secret here. So it's just a key value pair, hello secret, nothing fancy, super simple. OK, so next, in Vault, we usually create policies to kind of restrict access. You have this idea of a policy. So in this case, we're going to create a really simple read-only policy. So I'll show you the policy here. It's example read-only. It's very simple. You can see we are restricting only reads and lists on the path that's specified above, which is secret data KubeCon EU, so the secret that we just wrote. And then what we'll do is we'll create this policy. We'll say Vault policy write. And then this is going to be example read-only. I'll just name it the same name of the file. And the file is just right there. So we have successfully uploaded the policy to Vault. We'll read the policy back just quickly, just to show you I'm not tricking or like faking or anything. So we'll do Vault, I think it's read example policy, I hope. Read only. Yeah, so we've read it back from Vault, and that policy is successfully created. So next thing what we'll do is we'll create a Vault role. So role is like any other role in any kind of like RBAC system. You would have a role for developers, for production usage, for operators. Maybe developers can only read from production and write to dev clusters and things like that. So we'll create a role for our application to kind of start using it. So here I've already pre-created the role. So I think I can just do read. Oh, no one saw that. Read. Let's see. Oh. You know what? I'll type it. I'm not going to shortcut, go and try to do a shortcut. If I can remember the path. So it's going to be, I think, auth, Kubernetes, role, example. If I do this correctly, you're going to clap, because this is a long path that I don't know if it's correct. OK, OK, so it works. So, I don't know why you made you clap for that. Either way, but the Vault role is already pre-created. And what you'll notice here is it's bound to a service account in Kubernetes and also bound to that policy that we just created. I've also attached default policy, but you don't need to do that. In this case, we're just like attaching that to the example read-only policy that we just created. So we have a role, then we have a policy underneath, and we have a secret that we're kind of creating access to. So that's the kind of the setup in Vault. It's a one-time thing. And we haven't even touched Kubernetes yet. So now we'll kind of touch Kubernetes in this case. So I'll open a similar pod spec that you saw in Rita's example, exactly the same thing. We're using the same Nginx container. We're also mounting the secret and I think the same path. And then here in the volumes, you see a very familiar CSI block here with the driver, which is the Secrets Store driver. But instead of key vault, you see Vault, which is the HashiCorp vault. It's so confusing, so many vaults. And then the role name is the example role that we just saw in the previous example. Here I'm providing the address, and I'm keeping things simple. I'm providing an IP address directly to the Kubernetes service that's running Vault. I'll show you the Kubernetes service after this. And I'm also skipping TLS to make things easier. And not so secure. And then here in the object path, I'm going to select, instead of foo, I'm just going to enter KubeCon EU, because that's where we want to read from. And we'll read the hello secret, and that the value is just secret, what we stored, hopefully, if everything works. And you also have support for versions. So in the new version of Vault Key Value Store, every secret is versioned as well. So you can kind of figure out which version you want. By default, it's the latest version. So we'll just use the latest version. So I'll quickly show you the Kubernetes service here, kubectl get service vault. And then that's the IP address that I'm using for this demo. All right, so that's good. So now it's the nerve-wracking part of the demo. It's just, does it work, right? Like we will find out in 2 seconds. So we'll do kubectl apply and kind of create the pod. Now what will happen is the Vault CSI driver will pick this pod creation. We'll figure out, oh, it's using the Secrets Store CSI driver and using the Vault provider, and then do some form of authentication for us. So let's see how does that look. So we'll kind of tail some logs here. kubectl get pods, and then I'll actually see the wide view for this. If I can, oh my God. Okay, which one is it? So here it's running on node 1, I think it's v001. So let's actually see the logs for the driver that's running on that node. So kubectl logs, and let's tail the logs for that. Oh yeah, secret, thank you, Rita. Okay, so the container is Secrets Store, okay. So here you see a bunch of output. It's too big actually. I'm just gonna make it a little smaller. All right, so you see a bunch of output here. This is running in debug mode, so it's outputting everything basically. But that's the object that you saw was basically provided by the pod spec, and the driver has it now. So here's the interesting part. So wherever you see Vault is where you want to kind of pay attention. Here, so our driver has detected that the role name we want to use is example role, the Vault address is provided, and then it basically performs a Vault login using the JOT token. So Vault Vault today has support for Kubernetes as a form of an authentication method. So what we do is we use the pod's service account token, which is a JOT token signed by Kubernetes. We submit that to Vault along with the role name, and then Vault performs a verification process. It uses a Kubernetes token review API and make sure that the JOT token is valid. If the JOT token is valid, returns you back a Vault token, and then you can start interacting with Vault. So in this case, the driver will start retrieving the secrets that we've asked for. So here you see a very nice looking statement, getting secrets from Vault, but we'll see if it actually works. And then you see the Secrets Store CSI driver actually writing it to the container there. So moment of truth, we'll exec into the container in Nginx Secret Store inline and cat the mount Secret Store, which was our mount path, and the KubeCon EU, which should be hopefully our secret. All right, let's see. Should I do it? Maybe we don't need to find out, right? Maybe we don't have to do it. But OK, let's find out. So if I do that, you see the secret there, so which is great. So it works. So that's kind of the interaction on the Vault side and interaction on the Kubernetes side of the kind of the experience that we provide with this provider. Again, this provider is really super. It's very young. It doesn't have support for all the things that Vault does, but hopefully we can add support to it as we go on. So I'll switch back to the slides. OK. Oh yeah. Sweet. Yeah, so now what if you have to restrict access? Like basically have restrict pods to access only a specific secret store. So how do you do that? Maybe you label the pods and then restrict access. So how does that work?
So next, I have a demo that basically answers that question. Okay. So Azure Key Vault utilizes Azure Active Directory for access control and authorization. So one of the things that we developed was a Active Directory pod identity solution, which basically allows us to create a resource in the cluster that represents an actual Azure Active Directory identity. And then once it's created, then we bind that identity to some label selector. And then in your pod, then you can then reference that label selector and have that identity assigned to that pod. So once the identity is assigned to that pod, when the pod makes a request, it then uses that identity for all the requests that requires that identity.
Get the mic for you. To do it live. Oh, there you go.
No, I need to do it live now. Right. OK, so now I have the same exact cluster that I used earlier. So what I'm going to do is go ahead and deploy all the resources that are required to run the pod identity solution that I mentioned earlier. So the pod identity solution basically creates a bunch of CRDs. Basically creates Azure identity CRDs that actually maps to an actual Active Directory identity. So as you can see here, basically what I'm doing is I am creating an AAD identity, which basically maps to an Azure identity, and then the binding, which tells me, please bind this identity to any pod with these pod selectors, right? Label selectors. So here, let's take a look at one example. So as you can see, this looks exactly like what we had earlier, right? I'm still using the Secrets Store CSI Driver, and I'm basically using the provider name, but the difference here is as you can see here, the label selector says for AAD pod identity binding, use a name of the identity binding that I used earlier when I deploy the binding. And then once the binding is selected here, then in the driver itself, I'm telling the driver to use pod identity, and then I set it to true. So from that point forward, I'm using an Active Directory identity to authenticate against the Azure Key Vault instance. So I'm going to go ahead and create that particular resource as we just saw it now. And then once that's created, then let's see if that assigned identity CRD is actually created. OK, it was created. So what happens is this identity is assigned to the pod. So if we look at the pod that's created, and as you can see, in addition to the one that we created earlier, now I have a pod running with pod identity. And so similarly, let's see if we can see the secret coming back from Key Vault. And now, once again, I'm using an Active Directory identity. And hola.
Yeah.
Yeah. So yeah, so that demonstration was to show you that a particular secret store provider can provide the mechanism to provide some type of identity, right? So with that identity, then the pod can use that identity to authenticate itself. I know this is a huge requirement from a lot of the enterprise customers that we talk to. So this actually provides that capability. And we believe that a lot of the storage secret store providers out there will eventually have this type of identity solution.
All right, so in terms of the project status, you see a bunch of alphas there. So there's, you can download it today, you can experiment with it. So I would not recommend using it in production yet, for both the providers, for the Azure Key Vault and the HashiCorp Vault. But in the next little while, hopefully we can get them to beta and stable state as we go through some of the the user stories and use cases. So please provide your issues, your feedback. We'll give you some links after a few slides here to provide your feedback there, so we can figure out where we should add support and where we shouldn't. And then also, if you're a provider developer, you have some secret store you want to integrate, please feel free to do that. In the future, we are planning to add more providers. We are working with a few other folks to add a few different cloud secret stores as well. That would be super cool. And then also what Rita mentioned, the pod identity for more providers. So more providers. Currently, the Vault provider doesn't use the pod identity thing that you just saw. Hopefully, we can add that. And then also maybe an option to sync secrets into Kubernetes with one-way sync or something. That might be a cool feature. So in terms of resources, we will be tweeting out slides after this talk, so no need to take pictures, it's all good. The links are right there. So the Secrets Store CSI Driver is on GitHub here. It's open source, and both the providers have documentation on how to install it. So there's the first 5 minutes experience for you. It's tailor-made, so you can actually try it out and see what you think. So you can use Helm charts or YAML files if you like. And then also the the AAD pod identity project is also open sourced. And then there's also a Kubernetes key value key vault flex volume thing that Rita wrote, which is also open source. This might be a useful project for folks that are running the older Kubernetes clusters, which is probably a lot of us not upgrading clusters for some reason.
So pre-1.13, basically.
Oh yeah, pre-1.13, yeah. Thanks for correcting me. Yeah, so I think that project will work for the Azure Key Vault provider in the same way that you saw the kind of the Helm charts work and the inline support work. In this case, you'll be creating PVs and PVCs instead, basically. All right, so thank you to coming to this talk. We will be tweeting out the slides. I really appreciate it. You have some questions. Someone's already ready with a question. Oh my God, let me just conclude, and then,
A few minutes for questions.
Eager, I love that.
What about key rotation? Like, keys are not actually working if you do not have key rotation. How do you tell these volumes that there is a key rotation happening?
This is super awkward. So I don't know if it was obvious earlier when we showed the lifetime of the secret that is mounted is only the lifetime of the pod, right? So one way that you can do key rotation is by restarting the pod. And we believe that is something the application owner should actually do, because we don't want to actually control how the key is actually refreshed or loaded. So we believe that should be something that the operator or working together with the application developer to decide when do we rotate the secrets or certificates.
TTLs. Yeah, so that's probably a question for me. Yeah, so yeah, the vault TTL thing. Yeah, so as I said, right now we only support static secrets. So in the future, hopefully in the next little while, we'll announce how we're going to do dynamic secret rotation and things like that. And that's going to be a separate kind of problem. And you'll see how it all integrates. Currently, there's no support for rotating on a specific TTL. If the secret expires, then you'll get errors to going to the upstream database or something. So you might need to rotate it.
And also in terms of key rotations, I think we're also looking for feedback from folks in the community, because we hear both sides of the table. Some people want to completely manage it themselves. Some people want to actually let this thing take care of everything for them. So I think we need to provide a mechanism to let people do whatever they want. So definitely welcome the feedback and open issues so that we know how many people want this thing, and then give a thumbs up or something, or +1.
Question. So it looks like your solution only works at the volume layer, and it doesn't involve the Kubernetes secrets API at all. So my question is, if I want to use the Kubernetes API to create a secret, and I want that secret to go into Vault, how can we do that?
Is that for me? Can you take it? You're wearing the HashiCorp shirt. I'm just kidding. So yeah, so currently you cannot do that. So you have to create those secrets in Vault. So as I said, the Vault Kubernetes roadmap hopefully will be announced in the next little while here, and that'll have features that are out of band, which this project is not in the scope of this project. So you'll see some features that would allow you some feature. I don't know yet, but once it's announced, you'll see it will be publicly announced, and you'll get the story of how we want to go about those type of situations. But good question.
Right, and same goes for all the other secret stores, right? As you can see, option to sync to Kubernetes secrets is a question mark, meaning we definitely hear there are some people asking for it, but then we don't really know if everyone needs this. How important is it, right? Because if you're already in Kubernetes, maybe Kubernetes secrets is good enough, or maybe you want to say, I don't ever want my secrets to ever be in etcd at all, right? So in that case, this solution does just that, right? So it depends. So please let us know if this is a must-have feature for you.
For the providers, when I issue a request to the mounted volume, does that then translate to a back-end request on each read, or is it cached in the pod?
Oh yeah, could you repeat the question? Sorry.
When if I'm in the pod and I read the mounted volume and I get secret, right? Does that translate to a request to Vault each time, or is it cached?
It depends how you. It depends how the providers. It depends. Oh my God. how the providers implement it. So I know some providers have API limits, right? So it really depends. So currently, I think the way I'm implementing it is just I read in a loop through the array for the secrets and the types you want, and then make a request to get all of them. So it depends on how the providers implement it. Do you want to follow?
Basically, do you store a file of the secrets somewhere, or you make a call to this KMS or vault each time someone gets
Can you, sorry, repeat that? I didn't hear it.
Actually, we're out of time. That's the issue.
Okay.
We're actually out of time. If you have other questions, please come up and ask them directly.
Right. Thanks for coming
round
to
of
the talk.
applause, and please rate the session on the shed.